Hello everyone, we're going to go over LeetCode question 54, spiral matrix. Given an n by n matrix, return all elements of the matrix in spiral order. So we're given this matrix and the order in which the elements are added to the result are in this pattern. So you start with the first row and then you head down and basically spiral around until the center. The second example shows the same thing. So first row is complete, then you move to the last column for every row, then you move to the first column starting from the right in the bottom row, move up, and so on. So we're just going to visualize this question first and just get a better understanding of it. Okay, so if we take this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Yeah. So like I said, we want to process the first row. So this is the top row at index 0. And this is going to be the bottom row. This is going to be our initial starting column. So until we reach the end column, which we already know is the last element, we processed these three elements first. And now that the first row is complete, so we go from 1 to 2 to 3, we want to shift the boundary down so we don't access these elements again. Right? So we're just going to add this little squiggle here. And the next thing we do is process the elements at every row with the end column. Right? So we already have 1, 2, 3. This is going to be our result list. So we have 1, 2, 3. Right? And now we're going to process 6 and 9. So we're going to add 6 and 9 to our result. So this is going to be our result. Okay. And since we're done processing the end column for every row, we want to shift end column by 1. So now we shift this boundary over from right to left, if that makes sense. Since the top row is complete and the right boundary 3, 6, 9 is complete, we want to move this pointer to the left. So now this is going to be our end column. Right? Okay. And the next thing we do is process the last row, which is the bottom row, and until we get to the start column, which is still at index 0. Okay, so we're going to add 8 and 7 to our list. So 8 and 7. Okay, and now we're going to shift the bottom row up. Since the bottom row is already processed, we don't want to access these elements again. We want to add a squiggle here. Okay, and then we're going to add all the way from bottom row, while top row is less than or equal to bottom row, we're going to add the starting column. Okay, and then finally we're going to add a boundary to the left. So now that start column is all done, we're going to add this squiggle here, and the next thing we do is just process this last element. Okay, so we're going to have 4 pointers basically. So top row, which is going to shift down, end column, which is going to shift the right boundary to the left, bottom row, which is going to shift the bottom boundary up, and then the start column, which is going to shift the left boundary to the right. And we're also going to go through some test cases to make sure that the boundaries aren't overlapping. So I'll do that in a minute. First things first, I'm going to create the array list because we have to return a one-dimensional list. So we'll just say list of integer res for result equals new array list. Okay. And now for the pointers, we're going to say our top row is going to be equal to 0. And our bottom row is going to be matrix.length. So if you're familiar with 2D arrays or matrices, matrix.length will give you the number of rows, and we have to make it -1. Okay, and for the left and right, we're going to say the start column is 0 because it always starts at 0. And the end column is going to be matrix at index 0 dot length -1. So that's going to be the last column. Okay. And then we're going to return our array list at the end. Okay, so we know this is a simulation and we have to figure out when to stop the loop. There are different ways of doing this, but since we know that the boundaries can't overlap, we're going to continue this while the top row is less than or equal to the bottom row and start column is less than or equal to end column. That means there's no overlapping boundaries and we don't have to re-add elements that we've already visited. So while top row is less than or equal to bottom row and start column is less than or equal to end column, then we're going to start processing this. Okay? And first things first, we're going to just start with the first row. So just process first row. Right? Okay. So since we know we're at index 0 for the row, all we have to do is adjust our column. So what we're going to do is, let's see. Okay, so we need a pointer for int I equals start column. So I is less than or equal to end column, I++. Okay. And then we're going to start adding these elements to the list. So res.add matrix at index 0, or top row I should say, and I. So that's always going to change. Okay. And now that I should say top row. Now that the top row has been processed, we want to shift that boundary up or shift that boundary down. Then what we do is increment top row. So after this whole thing has been done, we want to shift it down by incrementing it. Okay. And now what we're going to do is process every row until we get to bottom, adding the end column. So this is the downward simulation. So then we can say process rest of the rows, and we're going to say while int I equals top row, I is less than or equal to bottom row, I++. And what we're going to do is add the last column, basically. So matrix at index I and end column. Okay? All right. And now that's done. So the next thing we're going to do is shift the right boundary to the left. Okay? So that means end column is going to be decremented. So what used to be end column, which is 9 here, we already processed that. So we're going to say the next boundary should be within these elements. We're not worrying about 9 anymore. So end column. And if you remember the condition where we don't want boundaries to overlap, this is the first one. So if top row is less than or equal to bottom row, right? So we want to make sure we're not like re-adding elements. Then what we're going to do is add elements from right to left, starting from end column. Okay, so for int I equals end column, which is this 8 over here, we're going to go all the way to the end. So I is greater than or equal to start column I minus minus, right? Because we're going from right to left, we have to decrement the pointer. And we're going to say res.add matrix at bottom row, because we're in the bottom row, and I. Okay. And if you want more of a visualization of how this might happen, this overlapping, let's say we have just a 1D array. So we just have 1, 2, 3, 4, right? So actually in this case, top row is equal to bottom row. All right, so they're all equal to 0. All right, and as per usual, we just process the first row. So starting from here all the way to 4. And then we still decrement end column, okay? But since top row, after we process this row, we're supposed to increment top row. So initially top row was 0. Okay, and after we process this row, we need to shift that boundary up here. So now that becomes 1. And since top row is greater than bottom row, which is 0, then we just don't process those elements, because we would be re-adding these elements if we didn't check that top row is less than or equal to bottom row. So hopefully that visualization makes sense, okay? Okay, so we add all those elements, and then what we're gonna do is shift the bottom boundary up. So if we shift the bottom boundary up, we actually decrement bottom row, because how matrices work, this is the greater elements on the bottom, and you decrement it, making it go up. All right, and then our next condition is if start column is less than or equal to end column, because we don't want the boundaries to overlap left to right. So then what we do is process end column all the way to, or start column all the way to end column. So for int I equals start column, I is less than or equal to end column, I plus plus. No, sorry, we start at I equals bottom row, since we're worried about the rows are being shifted. I is less than or equal to top row. Then we're going to do res.add matrix at index I, which is the row that gets shifted, at index start column. Okay? Okay, so we processed the first row, we shifted the row down, processed the rest of the rows at end column, we decremented end column and made sure that the boundaries aren't overlapping from top to bottom. We processed the elements from right to left by starting at end column all the way to start column. Then we shifted the bottom row up and added all of the rows at index or all of the rows at elements start column. And now we have to shift the boundary from left to right. So the last thing we need to do is increment start column. Okay. And if you want another example of boundaries overlapping, we can do it the other direction too. Right. So let's say we have 1, 2, 3, 4, so only one column. Okay. So we're still going to process this, 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 and this. And at this point, once we get to the last row, we're going to want, so start call starts at 0, and end call is also at 0 because, you know, this is the only column that we have. Okay. Once we get to the end, what we're going to do is shift end column to the left, which means this now becomes -1. Right? And now that the pointers are basically flipped, since start call is actually greater than end call, we would be basically adding these elements again. So we need to make sure that it's converging this way. So start call should always be to the left or equal to end column. All right, and let's make sure I didn't miss anything. Okay, let's see. 2, 6, 10. 2, 6. Okay. Let's see if I missed anything. Top row. Okay, end call, top row less than or equal to bottom row. Let's see. Okay, if start call is less than or equal to end column, then we start at bottom row. Okay, I is less than or equal to, oh, I is greater than or equal to top row, I minus minus, because we have to decrement it. Okay, so that test case works out, and let's submit it. Okay, so I just fixed that issue. This is a basic like 2D matrix problem. We just have to make sure the boundaries aren't overlapping. That's the part I struggled with at first, but this is a good way of solving it, and I hope the visualization helped too. So thanks for watching.